Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is lesson 18, Sampling Variability and the Effect of Sample Size. Okay, so classwork, example 1, Sampling Variability. The previous lesson investigated the statistical question, what is the typical time spent at the gym? By selecting random samples from the population of 800 gym members, two different dot plots of sample means calculated from random samples from the population are displayed below. Here we go. This first dot plot represents the means of 20 samples with each sample having 5 data points. The second dot plot represents the means of 20 samples with each sample having 15 data points. Okay, so here n equals 5, n equals 15. Based on the first dot plot, Jill answered the statistical question by indicating the mean time people spent at the gym was between 34 and 78 minutes. She decided that a time approximately in the middle of that interval would be her estimate of the mean time of 800 people spent at the gym. She estimated 52. Right here. Scott answered the question using the second dot plot. He indicated that the mean time people spent at the gym was between 41 and 65 minutes. He also selected a time of 52 minutes to answer the question. A. Describe the differences in the two dot plots. Okay, so the first dot plot shows a greater variability. It varies from the range is 34 to 78 as opposed to 41 to 65. So it's got a greater variability in the sample means than the second dot plot does. B says, which dot plot do you feel more confident in using to answer the statistical question? Explain your answer. Okay, a possible response would be, the second dot plot gives me more confidence because the sample means do not differ as much from one another. They are more tightly clustered, so I think I have a better idea of where the population mean is located. So rather than just being all spread out like this first one, these are more clustered together and they're starting to show some form of shape in the graph. Part C says, in general, do you want sampling variability to be large or small? Okay, the larger the sampling variability, the more that the value of a sample statistic varies from one sample to another, and the farther you can expect a sample statistic value to be from the population characteristic. You want the value of the sample statistic to be close to the population characteristic, so you want sampling variability to be small. Okay, exercises 1 through 3. In the previous lesson, you saw a population of 800 times spent at the gym. You will now select a random sample of size 15 from that population. You will then calculate the sample mean. Start by selecting a 3-digit number from the table of random digits. Place the random digit table in front of you. Without looking at the page, place the eraser end of your pencil somewhere on the table of random digits. Start using the table of random digits at the digit closest to your eraser. This digit and the following two specify which observation from the population will be the first observation in your sample. Write the value of this observation in the space below. Discard any 3-digit numbers that are 800 or larger and use the next 3 digits from the random digit table. Okay, we did this in the last video. So I will bring in the table that we're talking about here and we will switch back and forth from that. Okay, so here is the eraser end of pencil drop page you're going to use. And then you take the 2 digits after the one you chose to pick a value in one of these two. So this is what we did in the last video. So if I randomly drop my pencil here, then I would use these 3. 2, 7, 7 is my first choice. So I go to 27 and over to 7. which is right here. 27,7,277 generated 68. I'm going to do this 15 times. So if I chose this number, it'd be 390. So I go to 39,0. 39,0 is 28. And if I chose this number, 631, 63, 1 is 36. And then if I chose this number, then I'd use these three, 183, 18, 3, 51. Drop my pencil here, 299, 29, 9, 60. Drop my pencil down here, 095, 09, 5, 51. There's 6. About here. 672, 67, 2 is right here, 46. And we just keep doing this. Here's 1, 770, 77, 0 is 35. 032, 032, 81. Okay. Drop my pen here. 725. 72, 5. 31. There's 10. You got to do 5 more. How about right here? 264. 26. 4 is 57. 535, 53, 5, 59. 672, 67, 2, 39. 747, 74, 7 is 60. And one more time, 019. 019 is 51. So I did that 15 times. Then I get my calculator. Okay, so now we're going to calculate the mean. So I'm going to show you something different this time. I'm going to go to Math, Probability. Actually, before I do that, okay, I'm going to show you how to do this in the calculator, so if we need the data for something else, it'll be there. So this is a list of 15 numbers. So I'm going to press my Stat button here. We're doing statistics, so press Stat, and I'm going to edit a list. So I'm just going to leave it at 1 and hit Enter. And then I'm going to enter in list 1 these values. So I'm going to hit 68, Enter. 28, Enter. 36, Enter. 51, 60, 51 again, 46, 35, 81, 31, 57, 59, 39, 60, and 51. Now notice it says L1 15. That means there are 15 items in this list, and that's what I needed. So there is my list of 15 numbers all the way up to here, L1 15 numbers. Okay, so now that I've got that entered in list 1, all I do now is hit Stat, arrow over to Calculate, and we're doing one variable statistics. So I hit Enter. And we're going to use list 1 and just hit Enter until it calculates. And the X bar is our average or our mean. So our mean in this problem is 50.2. Okay, so why I'm showing you this is because later on we're going to see other things and we're going to use other things. We're going to use the sum of all the x's was 753, and then divided by 15 gave us 50. And then the sum of all those numbers squared is used in another formula, and then the standard deviation, and then that's n is our number of items. The minimum was 28, so it tells us our minimum. The maximum, or that, and then quartile 1 was 36, the median was 51, quartile 3 60, and the maximum was 81. So there's the maximum right here, 81. So there's some important information that it calculates for us quite quickly if we just put that into a stats table. Okay. Okay, so now I've got everything all cleaned up here. And so it said, write the value of observations in the space below, did that. Okay, now it says continue moving to the right of the table of random digits from the point that you reached in exercise 1. Each 3-digit number specifies a value to be selected from the population. Continue in this way until you have selected 14 more values from the population. This will make 15 values altogether. Write the values of all 15 observations in the space below. Okay, so I didn't do that last part correctly. They just wanted us to drop the pencil on the paper once, and so I will do it here on number 2. Okay, so what they wanted us to do in this last part, that's okay what we did, but what they wanted us to do is just drop the pencil one time. So say we dropped it here and got 646. So we're going to do it now for this next part. So let me just move this table. Actually, let me move the page so I can see what we're doing now. So we're going to continue moving to the right. So let me move these down so I can write my answers in the space provided. Okay, so where did we end up? I don't know, let's try 395. So let's say it landed there. So I chose 395. So then I go to 39, and 5 is right here. So that's 51. So this time we want 14 more, so there's 1. And then we want 993, but that's more than 800, so we skip it. Then we do 293, so that would be 29, 3, which is 49. And this is what we were supposed to do in number 1. 919 is bigger than 800, skip it. 055 is 055, which is right here. Okay, and we're just going to continue down the table. 142, 14, 2 is right here. 40. And then 025 on the next row. 025 is 57. Okay, that's 5. 408 is the next one. That's 40. 8, which is 46, and 170 is 17, 0, which is 50. There's 7, we're half done. 713 is 71, 3, which is 61. And then we're going to do 043. 043 is here, 60. 064. 064 is 51. 44, can't read that, I wrote on it. 448. Okay, so did I count correctly? 3, 6, 9, 12, 15, 18, 19, 20. So it went 4, 4, and then 1 more is 8. 4, 4, 8. 44 is here, over to 8 is 73. And then 605 is 65. 38. 488, that'd be 48. 8 is 61. And one more time gives us 277. That's 27. 7, which is 68. So there's 14 more values. Let's move this down a little. Okay. All right, so we also wanted to use the last one, so I'll just do one more. They do want us to have 15 values, so I will use the next value, which I just need to move this little, is 0, 1, 0. So 0, 1, 0 was 50. Okay, so there's 15 more values. Okay. Okay, now it says calculate the mean of your 15 sample values. Write the value of your sample mean below. Round your answer to the nearest tenth. Be sure to show your work. When it says that, we can't just plug it in the calculator and write a number. So I'm going to show my work. 51, 49, 69, 40, 57. I'll add them up in groups of 5. 9 and 1 is 10, 19, 26. Carry the 2. 5, 6, 7, 11, 17, 21, 26. So I've got 266 on the first 5. So now that brought me to here. So now it's going to be 46 plus 50 plus 61 plus 51, or 60 plus 51. I'll do 5 at a time. 6, 7, 8. 5 and 4 is 9. 15, 21, and 5 is 26. And that brought us up to the 51, which is here. So and then I'll do 73, 38, 61, 68, and 50 gives us 15. 8, 9, 10, 11, 12, 20, carry the 2, 9, 12, 18, 24, and 5 is 29. So now I'm going to take that 266, the 268, and the 290. And 8 and 6 is 14, 6 and 6 is 12, and 1 is 13, and 9 is 22, and 2, 4, 6, 8 is 824. 15 goes into 824. 15 and 15 is 30, 45, 60, 75. 5 times is 75. That'll leave us with a remainder of 7. And bring down the 4, and that's 4, and that's 60, minus 14, bring down a 0, and that'd be 9. So it's 9 times 5 is 45, 9 and 4 is 13, that will be a remainder of 50, that'd be a 3, and it says round your answer to the nearest tenth. So I only have to go out to the hundredth to see if that's bigger than 5 or not. And that would be, and that is going to repeat now. 3, 3, 3 repeating. So my mean is 54.9. And I really should use an approximation because I rounded. Exercise 4 through 6. Now you will use the sample means from exercise 3 to enter for the entire class to make a dot plot. Write the sample means for everyone in the class in the space below. Okay, so what I've done here, since I'm not in a classroom setting, was I took the mean from number 1, 50.2, that's right here. I took the mean from number 3, which was 54.9, that's right there. And I used a random integer generator and just moved the decimal over 1 with my calculator to come up with 7 more to make up a pretend class of n equals 10. Okay. So write the sample mean for everyone in the class in the space below. Write the sample. So it says you will now use the sample means from exercise 3 for the entire class to make a dot plot for write the sample means for everyone in the class in the space below. Okay, so here they are. There's 10 of them. Okay, and then next question says use all the sample means to make a dot plot using the axis given below. Remember, if you have repeated values or values close to each other, stack the dots. So I'm going to bring these values over so I don't have to keep going back and forth. Okay, so here they are, and we're going to plot these. 50.2 is right about there. 54.9 is here. 50.3. Now they said if they're close, stack them. So 1/10, I would just stack. 48.1 would be here. 54.7 would be close to 55. I'll put that there. 40.8 is down here. 60 is here. 46.8 I skipped, which would be here. 44 and 56. Okay, so there's the dot plot of the imaginary 10 class. 6 says, in the previous lesson you drew a dot plot of sample means from samples of size 5. How does the dot plot above of sample means from samples of size 15 compare to the dot plot of samples from means of sample of size 5? For which sample size, 5 or 15, does the sample mean have the greater sampling variability? Okay, this isn't very clear, but the only way I could go back and do this was to take a screenshot of the video from the last lesson. And here is our sample mean dot plot that we were supposed to compare to this one. So our range went from 41 to 70, and now it's 41 to 60. And this is starting to get narrower, and it's starting to cluster up and start to take shape, where this was just all flat, no values that were repeated that were stacked. There was no stacking here. Stacking began here with a smaller sample variability. Okay. So which sample size, 5 or 15, doesn't mean have the greater sampling variability? Well, the greater variability was in the 5. It was spread out more, and it was not starting to stack like this. Okay. Now, this exercise illustrates a notion that the greater the sample size, the smaller the sampling variability of the sample mean, which is what we have here. Exercise 7 and 8 says, remember that in practice you only take one sample. Suppose that a statistician plans to take a random sample of size 15 from the population of time spent at the gym and will use the sample mean as an estimate of the population mean. Based on the dot plot of sample means that your class collected from the population, approximately how far can the statistician expect the sample mean to be from the population mean? The actual population mean was 53.9 minutes. Okay, so if I looked at this, I would probably think that the center of this data was probably right about here, around 50 or 51. And they said the actual was 53.9. So we're off by maybe 2 minutes, which is pretty close. So it says, approximately how far can the statistician expect the sample mean to be from the population mean? And I'd say approximately 2 to 3 minutes in our situation here. How would your answer in exercise 7 compare to the equivalent mean of the distances in the sample of size 5? Okay, so if I go back, so we're looking at this here, and our sample mean might be between 70 and 40. The middle might be 55. So if I think of that as being 55, okay, so in our situation, 55 is still pretty close. It's actually closer in this case. It's only about approximately 1 to 2, but it's higher. It's above where we were below. Exercise 9 through 11 says, suppose everyone in your class selected a random sample of size 25 from the population of time spent at the gym. What do you think the dot plot of the class's sample means would look like? So now we're doing a sample size of 25. Make a sketch using the axes below. So if the 10 people, remember there's only 10 of us, but each of us are choosing 25 now instead of 15, and before that, that was 5. And the 5 was just the spread out dots, and then it started to take shape. Now I would say it would probably look something like this. So I might think that maybe it'd be, here's 1, 2, actually maybe I'll move them in. Let's do this. 3, 4, 5, 6, 7, 8, 9, 10. I might think they might start getting narrower and sharing more values, so we have to do more stacking. With sample sizes of 25, we'd be getting closer and closer to, and actually I might want to move some of these points too. So let me do that. So the actual average was 53.9, so I probably want more over on this side. So it might look like this, more centered around that 53.9, which is right here. Number 10 says, suppose that the statistician plans to estimate the population mean using a sample of size 25. According to your sketch, approximately how far can the statistician expect the sample mean to be from the population mean? Okay, well, we could expect it to be anywhere from 3, I'd say approximately 3 to 4 minutes. And going back here, we could actually expect it to be from 41 to 60. I'd actually change my answer to that and say approximately 10. I'd probably say approximately 10 minutes for the 15, and even more, because if I'm looking at the range, this might be 15 minutes off. Okay. 11. Suppose you have a choice of using sample sizes 5, 15, or 25. Which of the three make the sampling variability of the sample mean the smallest? Well, the 25 does. Why would you choose the sample size that makes the sampling variability of the same sample mean as small as possible? Because the smaller the sampling variability, the closer the sample mean will be to the population mean. Now let me revisit exercises 7 and 8, and I'm going to do something differently here. If we take the values that we have here, okay, and number 7 says, suppose that the statistician plans to take a random sample of size 15 from the population of time spent at the gym and will use a sample mean as an estimate. The actual was 53.9 minutes. Well, if we know what the actual mean is, we can take differences of the actual mean from what we got. So let me move these values down here. And I can find an average distance. And that's what this question's actually doing. We could estimate by looking at the dot plots, but we can also do this. I could say, well, 53.9 minus 50.2. and 50 and subtract it from all of these. And obviously we're going to take the absolute values of these because distance is positive. Okay, and if we do this, I'll have 53.9 minus 50.2, 54.9. I'll just do this one time. And just keep doing this here. Let me just write 53.9 5 times. And subtract the values we actually got. And we're taking the absolute values of all these, okay? Absolute value. 53.9 minus 50.2 is 3.7. 53.9 minus 54.9 is -1, but the absolute value of -1 is 1. 53.9 minus 50.3 is 3.6. 53.9 minus 48.1 is 5.8. And 53.9 minus 54.7 is 0.8 absolute value. So these are all absolute values, remember. And I keep doing that. And 53.9 minus 40.8 is 13.1. 53.9 minus 46.8 . Maybe I should just keep showing this rather than trying to do it in my head. Okay, so we have 13.1, and then I want 53.9 minus 46.8, and that's 7.1. 53.9 minus 60 Okay, that'd be 6.1 absolute value. 53.9 minus 44 is 9.9. And 53.9 minus 56 is 2.1. So then we would take the average of all of these. So I'd take 3.7 plus 1 plus 3.6 plus 5.8 plus 0.8 plus 13.1 plus 7.1 plus 6.1 plus 9.9 plus 2.1. And I got 53.2, and I divide that by 10, and I got 5.32. That would be the approximate distance that we'd expect to be away from the mean, doing it with the average distance from the population. Okay, so about 5.32 minutes. We would do the same for exercise 8 with the sample size of 5. I'm not going to take the time to do that, but it would be a larger number than 5.32, and that would show that the larger the population, the smaller the distance you will be from the actual. So in answering this question, you would say that choosing that a sample size of 25 makes the sampling variability of the sample mean the smallest, which is preferable because the sample mean is then more likely to be closer to the population mean than it would be for the smaller sample sizes. Okay, that is the end of lesson 18. Go do your problem set.